Hi, welcome to solveandgo.com. This video is a continuation in a series of videos of solutions to the final exam from 2010 in Math 135. This video is going to show you the solution to question number 11, which is a question about exponential growth. So here's the setup. So at noon, a bacterial culture has a population of 2,000. At 1 p.m. the population is 2,200. So assuming exponential growth, what's the population at 3? What is the population at 3 p.m.? Okay, so that's the question. Okay, let me remind you of the formula. This is just a formula you should know for exponential growth. Population at time t is the population at time 0, so the initial population, times e to the kt, where, as I said, p0 is the initial, in this case, population, and k is called the decay or growth constant. In this case, it'll be growth. It'll be a positive number, growth constant. Okay, so let's see. We need to find P0 and we need to find K. Well, P0 is given. This is the population at the beginning of the problem. So by the beginning of the problem, what I mean is the initial time, which we're going to pick to be noon. Okay, so noon for us will mean the time t equals 0. Okay, so at t equals 0, we have P0 is 2,000. Okay. Okay, so I'm going to erase this problem, assuming that you have it copied down, or that you can pause the video and do that. Okay, so let me remind you what we have. Here's the general formula for the population at time t. T will be in hours for us. It's P0 times e to the power of kt. And we know P0 is 2,000. E to the kt, and we need to find K. So we'll use the additional piece of information we're given, and we were given that at 1, so this is P of 1, the population is 2,200. Okay, so 2,000 times e to the kt should equal 2,200, and we're going to solve for K. What we get is e to the kt is 2,200 over 2,000, which is 22 over 11 over 10. And so from here, what we get, so we can fill in, just go back here, but we can fill in a 1 for t. Right? We don't need to leave it as t. We know we're looking at the population at 1 p.m., so fill in that 1 for t. So e to the k is 11 over 10, which means k is ln of 11 over 10. Okay, so review your log rules if that's unfamiliar, but that's the value of k. All right, so let's plug this back in to get a formula for p without any unknowns. So it's 2,000 e to the kt. So k for us was ln of 11 over 10 times t. And I could rewrite this using exponent properties and properties of log and so on. What we get is e to the power of ln of 11 over 10, and then that's raised to the power of t. And then e to the power of ln of x x is x. So in our case, x is 11 over 10. So we write this as 2,000 times 11 over 10 to the power of t. Okay, this is because e to the power of something and ln are inverse functions. Okay, and the question's asked for the population at 3. So this is p of 3, which is 2,000 times 11 over 10 to the power of 3, which is 2,000. 10 to the power of 3 is 1,000, and then 11, so it's times 11 to the power of 3. So we end up with 2 times 11 to the power of 3, which if you calculate it ends up to be 2662. Okay, and that's the solution and answer to question number 11.